Welcome back after the short break. Now it's time for the next lecture by Sebastian Czech, entitled Building Infrastructure as a Code Using Test Later Development Method. Great applause for the Sebastian and enjoy the lecture.
Okay. So, hello, hi, I'm Sebastian Czech, and today I will be talking about building infrastructure as a code using test later development method. During my lecture, I want to focus on three things. At first, I want to talk about test pyramid. I will explain test types. Then I will explain test later development method and compare it to different approaches which we can use. And at the end, the longest part, it will be live demo, during which I want to show you in a practical way how to do every type of test listed on the slide. So let's start from test pyramid. This test pyramid, as presented in the slides, is a classical approach in which we have a lot of unit tests, a smaller amount of contract tests, integration tests, and then the smaller number is the end-to-end tests and manual tests. In software development, sometimes there are used different approaches, like inverted test pyramid, when we have a lot of end-to-end tests. Sometimes there is used test diamond, in which we have a lot of integration tests. But why this approach seems to be the best way for the infrastructure? I will answer for that question in a moment. At first, I want to explain what every type of test is needed for. Of course, I will be talking about it in the context only of the infrastructure. So unit tests help us in answering question if the configuration which we prepared is correct. For example, if all required attributes were provided for all resources. Contract tests help us to check if for the input data, so for the values of the variables, we delivered values which matching our expectations. For example, when we have a variable subnet IP net mask, then we are expecting that for this variable, we will provide a string in proper format. Yes, so it will be an IP address and net mask provided for that variable. Next type, integration test, is mainly used when we have a bigger infrastructure and we are splitting it into many modules. Then integration tests help us to check the behavior of every module. If every resources created by that module are provisioned properly. End-to-end tests, so as the name is suggesting, are testing whole infrastructure, and they are answering question if the infrastructure which we prepared can be used by end user. Manual tests I will skip in my presentation because I focused on tests which we can automate and which we can put in CI/CD pipeline. And answering for the question from the beginning, why that approach seems to be the best for infrastructure as a code. When we take a look on the costs, I mean on the money and time, the cheapest are the unit tests and the most costly are end-to-end tests and manual tests. So that's why it's best to have a lot of unit tests, contract tests, and then few end-to-end tests because of that fact. So now when we know what test pyramid is, we know test types, let's think when to do testing. So here we can have few approaches. One of them, TLD, test later development method, is very straightforward approach in which we are at first focused on working code for our infrastructure. And when that code is ready, we are refactoring that code. The latest stage is preparing tests. And then maybe somebody can ask, what is the reason to do tests at the end of our work? So I can provide at least two answers for that question. If we have a test which we can automate and execute on test environment, acceptance environment before going on production, then we have a higher confidence that what we prepared is really working. Second reason why to write this test is when in future somebody else will take our code, then he or she, if we'll change something in that code, then using that test we can check if something was broken by that person or not. Okay, so we know that first approach, of course. In a moment, I will show other approach, okay? So test-driven development method. Here we have different approach when we are starting our work from writing a test, but that test at the beginning should fail. This is not an easy task to write a really valuable test which is failing at the beginning. And what is the next step? After we have that kind of test, we are making as small amount of code as possible to make that test passing. If the test is green, we are refactoring our code and we are starting next cycle. So we are doing as many iterations as needed to deliver the final solution. So when we compare the two approaches, this is my personal opinion, why we should use TLD for infrastructure as a code instead of TDD. I am providing here on the slide 4 reasons. One is development time. In TLD, we don't have as many iterations like in TDD. Second reason, learning curve. Let's say in DevOps world, we have a lot of people with dev background, but also we have a lot of people with ops background. And not for everybody, it's easy to learn TDD approach and writing valuable tests which are failing at the beginning. This is not an easy task. Third reason, increased productivity. In TLD, we are focused at first on working code. On TDD, we are focused at first on working tests. And code simplicity. I think that code driven by the test, like in TDD, can be a little more complicated than it could be using the first method. So I think that is enough for theory for a moment. Now I will prepare you, I have prepared a short demo. For the demo, I have prepared small infrastructure. Everything what you see in that picture was prepared in Oracle Cloud. Why I choose Oracle Cloud, not AWS or GCP? I will answer at the end of the lecture, not now, but there is one reason for that. In that region, we deployed 2 networks, VNC demo and internal. In demo network, we will have 2 subnets, one public, one private. Of course, we will have security rules, root table, and internet gateway because we have a public subnet here. And both networks are connected via dynamic routing gateway. And that internal network doesn't have a enter to the internet. This is only private subnet here. So in a moment, I will switch to the code, and I will show you every type of test which we have in that test pyramid. So we will start from very simple tests, unit tests. I hope that it's visible. So let's start from, if we, at the end of the lecture, I will also present a set of links. One of the links is the link to the article from HashiCorp, which is describing in detail that test pyramid. And in that article, we can find that the first 2 commands recommended as a unit test are, one of them is Terraform validate, which is checking the syntax of our configuration. So in that case, we are checking if all required attributes are defined. So of course, in that code, I have by purpose made mistake, which we will fix quickly. So if you go to the modules network VCN TF, we will quickly fix missing compartment ID. Compartment is very specific for Oracle Cloud only. but this is not the subject of that meeting. So we will quickly fix the configuration. And now Terraform validate is successful. Second command, which Terraform in his article is recommending, is Terraform fmt. And here we can check if the format of our code is properly defined or not. In that case, not. So of course we can fix it. We will not do it manually. We will also use Terraform fmt command, which will automatically adjust code to the standard formatting described by HashiCorp. So now, when we one more time do check, everything is okay. So that was the simplest part. After every type of test, I will present a toolbox. At the end of the presentation, we will have a toolbox with all tools which we can use for every type of test. So for unit test, we have Terraform fmt and Terraform validate. Now we will go to, I hope, more interesting part, contract testing. And we will start for variables validation. So now when we have this code ready, according to the workflow described by Terraform, when the code is ready, we are doing planning. So let's do plan of our deployment. Is it successful? If it's successful, let's deploy it on our environment. And I hope that now, in a moment, we will have an error. Which we will try to fix. So as you see, the error returned during the deployment is error 400, that the CIDR value was unable to parse. Of course, this is invalid value at the end if you see the net mask. I have done it by purpose, but from the end user perspective, this is not correct behavior because planning was successful, deployment has failed. And what we can do to have this kind of error during planning? So we can introduce variable validation. And how we can do it? Let's adjust our variables by putting that validation. Before we did, I will show you only the glue code. In the glue code, when we are executing the every module, we are doing it for, we are passing a lot of networks here, a map of networks. In our case, as you see, we are passing to our module two networks, demo and internal. So we have to check that expression for every network which we are passing to our module. So let's go to the variables and let's prepare that kind of site validation. So we will put condition. That condition has to be true for all networks, so we will use all true. And then for every network in var networks, we have to check if we can make site netmask from the variable which we shown during the deployment. So that was the VCN site block. So we will check if we can make site netmask from that string. And need to also put error message to not to forget. So invalid IPv4 CIDR block for VCN. So when we have this validation, let's check if it works during planning. Let's do make plan. And now you see that we have an error during Terraform planning. That value is incorrect. So I hope that you see that improvement in our code. Let's adjust then the value of that virtual network. So let's fix the mask. And now plan should work correctly. Yes, so let's do deployment. Deployment will take 2 minutes, 2 or 3. So during that time, I want to show you 3 things. One of them, I'm using every time this make file and make commands. So at the end of the presentation, I will share the link to the repository where you can download the code and check what I'm presenting here. And all commands are in the make file, which I'm using during the lecture. Second thing which I wanted to show you, in the glue code, we have everything is configured by modules. So if we want to configure that networks, we are passing the network as a map to module network. Similar thing we are doing for module router. That routing between that networks, we are also configuring by that module, and we are passing the map of networks which are needed to configure. And the last part is module VM. Here we are passing 3 objects in that map because we want to configure 3 VMs as it was presented on the picture. And next thing which I wanted to show you, let's go to the Oracle Cloud and see if we have this networks configured. I hope yes. So in every network we have, in the demo network we have this 2 subnets, public and private, which we configured. We have also 1 root table, 1 internet gateway because we have a public subnet here. And we have also security list to make some access list to access that virtual machines in that network. Besides that, we have also that dynamic routing gateway, which is connecting both networks. So he is visible here. And we can check that we have 2 attachments to 2 networks, which we configured. We have also root table. And here we have the CIDR addresses which we have in the TF-vars file. And the last things which I wanted to show you is instances. So we should have 3 of them. So in a moment I hope that deployment will finish, and then we can go further with the next demo. So let's try to log into that virtual machine, if it works or not. So of course it's not working, but this is done by purpose. We don't have a lot of time for investigation, but I will show you what is the reason. Even if the plan was successful, deployment successful, but something was wrong in our configuration. When we go to the networks, virtual cloud networks, and to demo, and we will check the routing table, we see that we have only path to the dynamic routing gateway. We don't have a path to internet gateway. So how can we improve our code in that case? So if we assume that every network should have a defined default path, then that situation, that missing part, can be detected during Terraform planning. So let's fix that our code and add additional variable validation. This time we will do it in module network, module router, and we will add validation. This time it will be a little bit more complicated, but I will show in a moment. So of course we have to check it for every network. And then in the route rules, we have next map. And here we have to check if at least one of the routes is configured as default one. So we will use now function untrue, because we need at least one that kind of route present in that map. And what we'll check? We will check for route in network. The name is route rules. And we will check if the route destination is equal to default one. and error messages are so mandatory. So at least one route should be defined as default. Let's say something like this. So let's try now that validation rule. Let's do plan. And you see that we detected that we have missed something in our input data. So let's fix our input data, our tf-vars file. So let's add missing default rule. So destination has to be, as we were talking a minute ago, 000/0, and target internet gateway. So let's do plan. I have made some mistake. Yes, sorry. Thank you. So now our plan is okay. So let's deploy quickly the changes. And let's try to SSH to our machine. So now the routing is okay. So let's destroy it and we will move to the next part. So I have shown you variable validation. Similar approach we can do for resource. We can use lifecycle conditions, and here we have two options. And for that, I will only show you only the code, which I have prepared in module VM. For resource, which is creating instance, virtual machine, I have prepared two lifecycle conditions, preconditions, because besides preconditions, we can also use postconditions. So we have two options for resources. And here, what examples I have prepared. One of them is, for example, checking the how old is the image which we are using here. And if the image is too old, then we can, for example, reject deploying this kind of resource to our infrastructure. Second validation is checking the firmware. So if the firmware is not compatible with our expectation, we can also reject that deployment. So here we have a lot of options which we can use pre and post deployment of the resource, and both methods, so validations for variables and lifecycle preconditions and postconditions, can be used as a contract test for our infrastructure. Okay, so let's move to the next demo. Integration tests. Integration tests, as I was talking at the beginning, are checking the behavior of the modules, and we can use few approaches, few frameworks for that. One of them is a Terra test library, where we are preparing the test in Go. If somebody likes Ruby, there is a kitchen Terraform, but I have prepared these examples in Go, which I will show you now. So all tests, integration tests and end-to-end tests I prepared in folder test, and integration test for module network I have prepared. I have prepared tests for two behaviors. One is for, let's say, happy path. So when the configuration is correctly executed and resources are deployed properly. Here we are passing where we have our code, Terraform code for the integration test. It's a different code which we are deploying here, because we are using, if you go to that folder, we are using only here module network, and we are configuring only one network. Because here we are only interested if the module network is working correctly. We are also passing some var files and variables defined as a string map. What is also interesting, even if our tests fail, always the destroy of the infrastructure is executed as a defer action. So this is as a given. And what actions we are do now? We will do init and apply for our Terraform resources. And in assert section, we will check if the subnet ID, public subnet, is not empty. But of course that test is not finished, so we will finish it now. So we will use Terraform output, and here we will use Terraform options, and the name of the variable. Name of the variable we can take, of course, from our module. It will be that one. So it will be the first test for happy path, and second test which we have prepared. We will check if we will put incorrect data. So as you see, we are putting incorrect net mask. We want to check if we will receive an error message that our configuration input data are not correct. So how we can check if the error appeared? So we will use assert error, and here we'll get our variable error, and then we need to also check the message which is in the displayed in the error. So let's prepare that message. So error message. So this is one thing, and then now we will compare if the error message is what we have in expected values. Okay, so I think that's enough. So let's run our integration tests. We will go only to the directory tests, and we will execute make integration test. And you will see in a moment that in Go, using that TerraTest library, the initialization of the environment is being executed, and then apply. And immediately after creating that simple module, TerraTest will destroy that infrastructure. Let's wait only for a moment, and so let's move to the testing the happy path. So happy path also successful. We see that destruction of the modules of the resources, and a little bit up we should see also. It's difficult if I have so small font size on my computer, but here we have that output value which we are checking in our assert function. And the incorrect behavior, so the second test, we see that during the putting incorrect data, our planning has failed. Okay, so let's go back to our toolbox. So for integration tests, we can use Yes, the second test was testing the error. And here we are by purpose checking if we have error thrown by TerraTest. And we are using here only init and plan, not apply. So plan is enough to catch that error, yes? As we were showing before that, checking the side block for VCN. Okay, so I will go back to the toolbox. So these two tools I proposed, of course, this is not everything, but I have to choose something. And the last type of test, which I want to show you, is end-to-end test. End-to-end test I have also prepared in TeraTest, and we have only one test here. That test, as you see in Terraform there, is using the real infrastructure code, not as before for module. For module integration test, we have prepared other separated Terraform code, and here we are using our main Terraform code. And what we are doing here, we are applying whole infrastructure, and at the end we are getting the IP address of the public of the virtual machine running in public subnet. And next step, we are checking if we can do SSH on that virtual machine and check the host name. So from the infrastructure perspective, we are checking if the virtual machine which we deployed is accessible for other person. For, I don't know, for example, if that machine whole environment will be used by other team which will configure the application, provision application using Ansible playbooks. So then that person needs SSH access to that virtual machine. So this is what we are testing from the end user perspective, what we need. And we have 3 assert expressions. We are checking if the IP address is not empty. We are checking if we have no error while connecting to SSH, and comparing the name of the host name with the expected value. And I will execute that test, but we will not wait to the end, because deployment and destroy of the whole infrastructure will take in summary in 5 minutes. So I will only show you the code, but we will move forward with the presentation. So for end-to-end test, besides TeraTest, we can use many different tools. I was mentioning Ansible because sometimes Ansible we are using to provision the configuration on the infrastructure. So we can also use it for test, especially that Ansible has a nice callbacks which you can return test results in JUnit XML files. So we can easily connect it with all CI/CD tools like Azure DevOps or Jenkins and present in nice way the reports from the test. If we are provisioning web application on our infrastructure, we can use Selenium for end-to-end test and many more approaches which are not listed here. If somebody of you is interested in that subject, I have few links. The first is a great article on the blog by HashiCorp, in which you can find a detailed description of the test pyramid, which I was showing at the beginning. Second and third link are the great presentations by other people how to do, for example, TDD for the infrastructure. And the last is very valuable article about contract testings, how to define validation rules, lifecycle preconditions, postconditions. 3 key takeaways from that presentation, in my opinion. If you want to increase the confidence of the infrastructure which you deploy, I think it's good to test it in the ways, at least which I presented. We should use tools delivered out of the box by Terraform, like FMT and Validate. And for modules, which we are preparing for bigger infrastructure, we should focus on the behavior of that modules. If that behavior is correct, I could compare it to the testing classes in object-oriented programming. When we are testing the behavior of the class, so public methods, we are not testing the private methods or variables. If you want to play with that code, you can go to the first link from that slide. Second and third link is the answer why I choose Oracle Cloud. So some time ago, Cloudowski, I don't know if you know Tomasz Cholewa, have published ebook how to deploy for free Kubernetes cluster in public cloud. And I have, of course, that was manually, you have to do all operations. I have automated all those things in 2 different approaches. And using that code, which you can get from that my GitHub profile, you can provision your Kubernetes cluster and use it for free in Oracle Cloud, because Oracle Cloud is giving you 4 small virtual machines for free forever, yes. And this is nice for hobby projects if somebody is interested in. And the last link is link to Terraform registry, where I publish my modules for that Kubernetes cluster. So that's everything what I prepared. If you have any questions, please ask.